So here in section 4, we're going to see all of the trig material coming together, and our understanding of the unit circle and how that helps us find exact trig values will all come into play now. So first of all, we want to talk about one of the many identities, but probably the most useful, and I'm going to rewrite this in a way that's a little bit cleaner. We're going to talk about the tangent of an angle is equal to the sine of that same angle divided by the cosine of that same angle. As you move on in trigonometry, there are these things called trigonometry identities, proving two sides of an equation are equal, and you do a lot of substituting, and this happens to be a really useful property to substitute. It's also how we actually calculated tangent from the unit circle, so it's a pretty useful property. Additionally, there are 3 other trig identities, and they are cosecant, secant, and cotangent. And these guys are reciprocals of our sine, cosine, and tangent. So cosecant, abbreviated this way, cosecant of an angle is the reciprocal of the sine. So where sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. It's just flipped. Secant, SEC of an angle, is the reciprocal of cosine of an angle, whereas cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. Cotangent is the reciprocal of tangent. So we talk about tangent being opposite over adjacent, cotangent is adjacent over opposite. So again, dealing only with right triangles, we can now find 6 trig functions and trig ratios instead of just 3. We've already talked about the unit circle. One key concept is this idea of a reference angle, and we talked about this with the unit circle. But remember, a reference angle is the angle less than 90. We're going to say up or down from the x-axis. It's always positive. So when we have any sort of measurement, this angle down here, let's say it goes like this distance right here is my reference angle. And as we talked with the unit circle, if I know my reference angle and I know my signs on my quadrant, I can take that reference angle back to the first quadrant. There I know my sine and cosine values, probably even my tangent values, which means I know my cosecant, secant, and cotangent values. And then I put the appropriate sign for quadrant 3 onto it. So just remember, we always measure that reference angle from the x-axis. It's the distance up or down from the x-axis, and it is always less than 90. So let's look at some examples where we would maybe use a reference angle. The secant of 120. Now, I know that secant is the reciprocal of cosine. And so what I want to think about is, what is this reference angle? Well, my reference angle is 60 degrees, because to get back to 180, if this is 120, is 60 degrees. If I think about what is the cosine of 60, the cosine of 60 is 1/2. So the secant of 60 is 2/1. It's just a reciprocal. Then I have to think about my signs. In quadrant 2, cosine is negative. And so that means that secant is negative, and so the secant of 120 is negative 2. So it's combining the ideas of that quadrant and the reference angle, going to the unit circle, look up on the unit circle what is the cosine of 60. Cosine of 60 is 1/2. So 60 right here, we're in reference angle in quadrant 1, but our actual angle that we're worried about is existing over here in quadrant 2. Since everything repeats, we think about what are the signs in quadrant 2. Cosine is negative in quadrant 2, so my secant is also negative in quadrant 2. If I look at one that's just a straight up cosine of 330, yes, you could go straight to your unit circle, but if we're wanting to think about maximizing our ability to memorize, reference angle here is 30 because all the way around is 360. I've memorized 30 degrees, the cosine of 30, and you will have to memorize that next year. The cosine of 30 is the square root of 3 over 2. That's quadrant 1. Down in quadrant 4, my cosine is positive. And so the cosine of 330 is the square root of 3 over 2. Being able to use those reference angles maximizes your ability to work on the unit circle because you don't have to memorize all of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 coordinates all the way around. You just have to know what's going on in quadrant 1, and you can trans that over to quadrant 2, 3, and 4, and then apply the appropriate signs. So we'll do a couple more examples of some different kinds of problems in the next video.